Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss 3 more multiple choice questions in kinematics which requires higher ordered thinking to solve them. The questions are as follows. Question 1. A particle moving from A to B along a straight line has velocities u and v at A and B respectively. If C be the midpoint of AB and the time taken by the particle from A to C is twice that from C to B, then the options are V is equal to 3u, 3v is equal to 7u, 2v is equal to 7u and v is equal to 7u. Question 2. A train starting from rest from one station moves with uniform acceleration first, then moves with uniform speed and finally moves with uniform retardation and comes to rest at the next station. If the time intervals for the 3 parts are in ratio 1:8:1 and maximum velocity of the train is 60 km per hour, then the average speed of the train for the journey is, the options are 48 km per hour, 52 km per hour, 54 km per hour and 56 km per hour. Question 3. A particle moving with uniform acceleration has average velocities v1, v2 and v3 over successive time intervals t1, t2 and t3 respectively. Then v1 minus v2 divided by v2 minus v3 is, the options are t1 minus t2 divided by t2 minus t3, t1 minus t2 divided by t2 plus t3, t1 plus t2 divided by t2 minus t3, t1 plus t2 divided by t2 plus t3. Let us first solve the problem in question 1. The situation is shown in the figure. The velocity of the particle at A is equal to u, which changes to v at B. Let the uniform acceleration of the particle is equal to a. Let the velocity of the particle at the midpoint C is equal to x. Let the distances AC and CB are each equal to s. Therefore, the distance AB is equal to 2s. It is given that time taken by the particle from A to C is equal to twice the time taken by it from C to B. Therefore, if the time taken from C to B is equal to t, then the time taken from A to C is equal to 2t. Therefore, total time of journey is equal to 3t. Now, for the part AC, initial velocity is equal to u, final velocity is equal to x, time is equal to 2t and acceleration is equal to a. Using the kinematic equation, v minus u is equal to at we get x minus u is equal to 2at. Similarly, for the part AB, initial velocity is equal to u, final velocity is equal to v, time is equal to 3t, and acceleration is equal to a. Therefore, using the kinematic equation, we get v minus u is equal to 3at. From equations 1 and 2, we get x minus u divided by v minus u is equal to 2 by 3. On simplification, this gives 3x is equal to 2v plus u. Now, for uniformly accelerated motion, average velocity is equal to initial velocity plus final velocity divided by 2, and distance covered is equal to average velocity into time. Therefore, for the part AC, average velocity is equal to u plus x divided by 2, distance covered is equal to s, and time is equal to 2t. Therefore, we get s is equal to u plus x divided by 2 into 2t. Similarly, for the part CB, average velocity is equal to x plus v divided by 2, distance covered is equal to s, and time is equal to t. Therefore, we get s is equal to x plus v divided by 2 into t. Equations 4 and 5 implies that u plus x divided by 2 into 2t is equal to x plus v divided by 2 into t. On simplification, this gives x is equal to v minus 2u. From equations 3 and 6, equating the values of 3x, we get 3 into v minus 2u is equal to 2v plus u, which gives v is equal to 7u. Therefore, the correct option is D, which is the answer to question 1. Now we will solve the problem in question 2. The situation is shown in the figure, where the velocity time graph for the motion of the train is plotted. The train starts from rest at A, moves with uniform acceleration, and attains maximum velocity of 60 km per hour at B. From B to C, it moves with uniform speed of 60 km per hour, and after that it moves with uniform retardation and comes to rest at D. It is given in the question that the 3 time intervals are in ratio 1:8:1. Let the time intervals for motion AB, BC and CD is equal to t, 8t and t hours respectively. Therefore, total time of journey is equal to 10t hours. Average velocities for AB and CD are each equal to 30 km per hour. The train moves with uniform velocity from B to C. Therefore, average velocity for BC is equal to 60 km per hour. Now, distance covered is equal to average velocity into time. Therefore, distance covered in part AB is S1 is equal to 30t kilometers. Distance covered in part BC is S2 is equal to 60 into 8t, which is equal to 480t kilometers. And distance covered in part CD is S3 is equal to 30t kilometers. Therefore, total distance covered is equal to S1 plus S2 plus S3, which is equal to 540 kilometers. It may be noted that the total distance covered can also be calculated from the area under the VT graph. Now, total time of journey is equal to 10t hours. Therefore, average velocity for the entire journey is equal to total distance divided by total time, which is equal to 54 kilometers per hour. Therefore, the correct option is C, which is the answer to question 2. Finally, we will solve the problem in question 3. The situation is shown in the figure. We consider the motion of the particle in 3 parts. It is given that the average velocities in the 3 parts AB, BC and CD are V1, V2 and V3, and the time intervals for these parts are T1, T2 and T3 respectively. Now let the velocities of the particle at A, B, C and D is equal to U, X, Y and Z respectively. Using the kinematic equation V is equal to U plus AT, we get the following results. For part AB, X is equal to U plus AT1. For part BC, Y is equal to X plus AT2, which is equal to U plus A into T1 plus T2. And for part CD, Z is equal to Y plus AT3, which is equal to U plus A into T1 plus T2 plus T3. Therefore, average velocity for AB is given by V1 is equal to U plus X divided by 2, which is equal to U plus A by 2 into T1. Similarly, average velocity for BC is V2 is equal to X plus Y divided by 2, which is equal to U plus A by 2 into 2T1 plus T2. And average velocity for CD is V3 is equal to Y plus Z divided by 2, which is equal to U plus A by 2 into 2T1 plus 2T2 plus T3. Now, V1 is less than V2 and V2 is less than V3. Therefore, it is convenient to find the value of V2 minus V1 divided by V3 minus V2, which is equal to V1 minus V2 divided by V2 minus V3. Now, V2 minus V1 is equal to A by 2 into T1 plus T2, and V3 minus V2 is equal to A by 2 into T2 plus T3. Therefore, we have V2 minus V1 divided by V3 minus V2 is equal to T1 plus T2 divided by T2 plus T3. Therefore, the correct option is D, which is the answer to question 3. This completes the answers to the questions.